Bonjour. I'm still trying. I think by the end of this 2 weeks, I'll be very good. Just use a new language. So make our brain develop more. For 3.5, we're going to talk about implicit differentiation. In Chinese, we call that 隐性求导. So where this name comes from, you're going to see, I'm going to explain that to you later on. So let's do some exercise to warm this up, okay? So then you understand this better. Now, let's start with this function, phi x. If I differentiate phi x with respect to x, we're going to get phi. What about if the function here is phi y? Y here is a function of x, say x squared, right? So what happens when you differentiate phi y with respect to x? What should I put over here? Anyone?
You just put 5x squared or 2 to the x?
Okay. So if you have y and you differentiate this with respect to x, then you're going to get phi, this constant multiple in front, and then you're going to differentiate this y with respect to x, which is going to be y prime, okay? So we have y prime over here, all right? Now the y prime over here, notice that this y prime over here is equal to, now this y prime over here, when y equal to x squared, y prime is 2x. So if this is phi x squared, then you have phi times 2x, which is going to be 10x. Now you see the difference between this one and this one. When you differentiate phi x with respect to x, you get phi. When you differentiate phi y with respect to x, you get phi times y prime. So when this is a function of x, you will have to multiply this by the derivative of this with respect to x. In this case, it's y prime, okay? So different from x, this is a function of x. So you have y prime over here. So you have this extra. Well, I actually broke it down into step right here. So the outer function for this one, this is actually a composition of two functions. The outer function is y. When you differentiate that with respect to y, you get phi. And then the inner function is this y over here. When you differentiate that with respect to x, you get y prime, which is the same as dy dx. So the derivative of phi y is going to be phi times y prime. So you need the y prime there. Okay, now another one. X cubed, if I differentiate that with respect to x, I will get 3x squared. If I differentiate y cubed with respect to x, now again, if I break it down in this step, so this is actually a composition of this outer function with this inner function. Differentiate this outer function here with respect to y, I will get 3y squared, right? Okay. Differentiate this inner function, this y over here, with respect to x, what do I get? Y prime, right? Yeah, y prime. So when you differentiate y cubed over here with respect to x, then according to the chain rule, you get this times this. So you have 3y squared. By the chain rule, you have to multiply this by y prime. Okay, so I have this extra. You see the difference between this one and this one. This one here is just x. So you get 3x squared. This one here is not just x. It is a function of x. So you have to use the chain rule. So you get 3y squared, but you have to times the derivative of this inner function with respect to x, which is y prime. Question? This year is very stressful for me. Okay, anyway, okay, so come back over here. So we just got this, right? So the derivative of y cubed, when you differentiate this function with respect to x, you get 3y squared. But by the chain rule, we have to multiply by the derivative of this inner function y with respect to x. So you have to multiply by y prime. So I have this extra right here. Okay. Now what about this function, e to the x? Differentiate this with respect to x, you get e to the x itself. And now if you have e to the y, where y is a function of x, then what do you get? Everyone?
It's I.
So the outer function is e to the y. So differentiated with respect to y, you get e to the y itself. Okay. So by the chain rule, we have to multiply this by the duality of this inner function, which is y prime. So times y prime. So so we practice on this. Now you guys will be ready to move on to this new topic. Okay. So I start with this equation. We try to find y prime at this point 3, 4. Notice that this equation is the equation of a circle centered at the origin with radius phi. This point over here, it satisfies this equation. So if you substitute x equals 3, y equal to 4 into this equation is true. So this point is on the circle. So it's actually a good idea to double check if this point is on the circle or not. Otherwise, you cannot proceed like this. Okay. So this point is on the circle. We're trying to find y prime at this point. In other words, we're trying to find the slope of the tangent at this point. Okay. So I'm going to present you 2 different ways to do it. Okay. So first, solution 1. We're going to solve for y. To solve for y, we first isolate y squared. So y squared here is equal to 25 minus x squared. To solve for y, we take square root on both sides. So you have y equal to plus or minus square root of 25 minus x squared. Because this point is at the upper half of the circle, so you only take the positive root of this, right? So y is equal to positive root of 25 minus x squared. Now after you solve for y here, now you can differentiate this with respect to x. So the outer function is the square root function, okay? So think about this inside here as u, okay? So the outer function is square root of u. Differentiate that with respect to u, you gotta remember, right? So we remember we use it as a formula now. We did it many times. So it's 1 over 2 square root of u, okay? The inner function is this u equal to 25 minus x squared. Differentiate this inner function with respect to x, we get negative 2x. So y prime is going to be 1 over 2 times square root of 25 minus x squared multiplied by the duality of this inner function, which is negative 2x. And you simplify, you got this. Now you can substitute x equal to 3 into this x here to find y prime, and it turned out to be negative 3, 4. Okay, so that's one way to do it. Now today I'm going to teach you a new way to do that. That's called implicit differentiation. Okay, so implicit differentiation, you don't need to solve for y. Okay, so what do you do here? You're going to differentiate both sides of this equation with respect to x. Now, when you differentiate x squared with respect to x, you get 2x. What happens when you differentiate y squared with respect to x? So we did the warm up over here. What happens if you did, what happens when you differentiate y squared with respect to x? What do you get?
Is it the negative x or?
2 times y.
Oh, yeah.
The outer function is the square function. Differentiate that with respect to y, you get 2y. But that's not all. We have to multiply by the duality of this inner function, which is what? Y prime, right? So y prime, like that, okay? So you differentiate the outer function, the square function, you get 2y. And then we times the duality of this inner function, which is with respect to x. So that is y prime, okay? So you have this. So notice that when this is different from x, when this is a function x, then you have to do you have to use a chain rule this way. Okay. Now what about the other side? The other side is just a number, it's a constant. When you differentiate that with respect to x, what do you get?
0.
0. Yes, you got it. Now we're going to solve for y prime. So solving for y prime here, y prime is going to equal to negative 2x over 2y. And you reduce it, so it's negative x over y. I heard someone say negative x, so it's over here. It's negative x over y. Okay, so at this point, now we're trying to find y prime at this point on the curve. So we can substitute x to be 3, y to be 4 into this. So we get y prime is negative 3 over 4. Is this the same result that we got?
Yes.
Yeah, that's the same result as the first method. And this method is actually much simpler, right? You don't need to solve for y, and you can just go ahead and use this two steps. The first step, differentiate both sides with respect to x. Second step, you solve for y prime, and then you can just go ahead and substitute the x and y value of the point on the curve, and you can find y prime right here. Okay, so that's called implicit differentiation. So implicit over here, because you didn't solve for y explicitly, right? So it's called implicit differentiation. This method is particularly useful when the equation is hard to solve for y, or is complicated. So when it's very hard to solve for y, and sometimes maybe impossible to solve for y.
Can you only use it when you have two variables?
Yeah, we only have two variables, x and y.
But it can also be used on equations that has 3 or more variables. Implicit differentiation is useful because you don't have to solve for y explicitly.
So it's particularly useful when the equation is hard to solve for y, or maybe impossible to solve for y. So to find y prime, we will use the implicit differentiation. Okay. Now I'm going to warm you up for to prepare you for something more advanced. So let's warm up with this. So we went. The product rule is this. Okay. Now let's try to use the product rule to differentiate x times y prime. The y here is a function of x. So what do we get? So we're going to differentiate x first, right? Differentiate x, we get, okay, let's just put it down. Okay, so differentiate x first, and then times y, adding, now x times y prime, okay, according to the product rule. So that's equal to, x prime here is just 1. Okay, so that's just 1. So this is just 1. 1 times y is just y. So you have y here. And then adding x times y prime. Do you guys get it?
Yes.
Yes.
Okay.
Yes.
Okay. All right. So now, if you have a 6 in front of that function, then we just bring out this 6. That's a constant multiple. So you have 6 times this part over here. Put it down. Okay. Okay. Now we have x cubed plus y cubed equals 6xy. So we're trying to find y prime. Okay. Now this is y to the third power. This function here has degree 3. So it is hard to solve for y. And sometimes maybe impossible. Okay. So we want to find y prime using implicit differentiation. The first step will differentiate both sides of this equation with respect to x. Okay. Let's see what we get. Differentiate this side with respect to x. Differentiate x cubed here. What do we get? 3x squared, right? Differentiate y cubed with respect to x. We get what? 3y
Y squared.
But that's not all. Multiply by
Y prime.
y prime. Yes, you got it. Okay, y prime. Okay. Now on the other side here, we just went over, right? So the derivative here, 6xy will be 6 times this. So we have 6 times y plus. So we had done up here before. So 6 times this. So it will be 6 times y plus x times y prime. Okay. Now remember, we're trying to, okay, now I can distribute over here because we just try to find y prime. You have y prime over here and over here. So we want to distribute to free this y prime from the parenthesis. So you have, I don't think I need this. Okay. I'm going to take this part here away. Okay. So I can take this away. Okay, just like this. Okay. So we end up with this. Okay. Now we can solve for y prime. So first, I'm gonna divide both sides by 3. So divide both sides by 3. Then we're gonna get x squared plus y squared y prime equal to 2 times y plus 2 times x y prime. Okay. All right. So divide both sides by 3. You got this. Now you can solve for y prime. Okay. Go ahead and solve for y prime and see what you get. Now you can move this. Let's subtract both sides by 2x y prime and put them together. So you have y squared minus 2x times y prime. And on this side, you have 2y minus x squared. Now you divide both. Now you divide both sides by y squared minus 2x. Then you're gonna get 2y minus x squared over y squared minus 2x. Okay. So we have solved for y prime. Good. All right. Now we found y prime already. Part B here is to find the slope of the tangent at this point. First, I'm going to check if this point is on the curve. So I substitute x and y to these 3 here. It satisfies the equation. So yes, indeed it's on the curve. Now we're going to find the slope of the tangent. So we're going to substitute x to these 3, y to these 3 into this derivative, right? Okay. So substitute here. I'm going to get 2 times 3 minus 2 squared over 2 squared minus 2 times 3. So substitute x equal to 3, y equal to 3 into this expression for y prime. Then we're going to end up with -1. So the slope of the tangent at this point on the curve is -1. Now you can actually double check this by looking at the graph of this. Okay. We're going to do that later. Okay. You can actually double check. Okay. Part C over here. At which point in the first quadrant is the tangent horizontal? So which means the slope of the tangent will be equal to 0 at that point. So we're going to set the first derivative equal to 0 because the slope of the tangent is equal to 0. So we're going to set y prime equal to 0. So set y prime equal to 0. Y prime is equal to this, so we have this equal to 0. Now, for this quotient to be equal to 0, then the numerator will have to be equal to 0, and the denominator not equal to 0. 0 divided by a non-zero quantity will be equal to 0. Okay, so we'll have this numerator here equal to 0. So you have 2y minus x squared equal to 0. This comes from the slope equal to 0. Okay. Now, we need to solve for x and y because we try to find that point. So we need another equation. So that point is on the curve. So that point satisfies the equation. So we can write down the equation over here. So the equation for that curve is x cubed plus y cubed is equal to 6xy. So now we have the equation for that point. Okay, so for the x and y, we have 2 equations. So we're able to solve for x and y. Okay, so we can solve this by substitution. We can isolate this y from the first equation. So y is equal to x squared over 2. And then you can substitute this into the second equation over here. Okay, so let's label this equation 3. And we're going to substitute. Then we're going to get x cubed plus x squared over 2 cubed equal to, now when you simplify this, that will be x cubed plus x to the 6th power over 8 equal to 3x cubed. over here, you can subtract xq on both sides, and you can multiply both sides by 8.
I think it froze again.
Oh, it doesn't show. So now, where did it freeze? Let me go back a little bit. So over here, this equation, when you simplify this, you got this equation. You subtract xq on both sides. So this side you get 2xq. Now you multiply both sides by 8. So you get x to the 6 equal to 16xq. Over here, you don't divide both sides by xq. If you divide, you're going to lose one of the roots. So instead, you will subtract 16xq on both sides. So move it over. You got this equation. Now we can solve this by the zero factor property. So take out the common factor xq, then we'll have this. So will be either this factor equal to 0 or this equal to 0. To solve this, xq equal to 0, then x will be equal to 0. And to solve this, you have xq equal to 16. And so x is equal to 16 to the 1/3 power, which is equivalent to 2 to the 4/3 power. Okay. So you found the x coordinate of those points. However, you still need to find the y coordinate. So we plug y. So we're going to plug in x equal to 0 into this to find the y coordinate of the corresponding point. So plug x equal to 0 here, y will be equal to 0. So that point is 0, 0. If I plug x equal to 4/3 into this x here, then do the algebra, then y is equal to 2 to the 5/3, okay, power. So that point is the corresponding point. Now, but the question they ask is in the first quadrant. 0, 0 is over here, is not in the first quadrant. Okay, this point is not in any quadrant. It's at the origin. Okay, so that is not the point that they're asking. So this one here is the point they're asking. So in the first quadrant, at this point, the tangent line is horizontal. So that answers the question. So if you graph it, you see the graph of this equation will be like this. This point over here is right here, and it has a horizontal tangent over here. Over here at the origin also has a horizontal tangent, but that's not the point because that's not at the first quadrant. Okay. Question?
Yeah, I kind of missed where you solved for 0 and then you, I guess, made y equal to that.
Yeah, because notice the two equations that we have over here. Okay, this equation, this equation. Now, when you isolate the y over here, you get y equal to x squared over 2. So once I find this x value, the x coordinate, I can substitute that x equal to those value into this equation to find the y value. So y is equal to, substitute 0 here, 0 squared over 2 will be 0. Substitute x equal 2 to the 4/3 power here. Then you get 2 to this 2, you multiply the exponent. So 8/3, okay, the exponent. Now over here, when you divide, you will subtract the exponent. So this is 2 to the 8/3, and this is 2 to the first power. You subtract the exponent. 8/3 subtract 1 is 5/3. So the y coordinate is 2 to the 5/3. So x coordinate is this. Y coordinate is this, which is approximately this. So now at this point, okay, that point right there, the tangent line, this point here at the first quadrant, the tangent line will be horizontal. Okay. Does it answer your question?
It does, yeah, thank you very much.
Okay. Now the second example here. This equation is impossible to solve for y. Okay, they actually have this transcendental function mixed with algebraic function. It's impossible to solve for y. So to find y prime, we want to use implicit differentiation. So differentiate both sides with respect to x. That's the first step. So differentiate here. Notice that this is the outer function, right? This is the outer, and this is the inner function. Okay, and actually the y here is the innermost function. Okay, so differentiate here, we have to use the chain rule. Differentiate this outermost function sign, we get what? What do we get? The word here sign is
Cosine.
cosine. Okay, and then we just copy this cosine of x plus y. Okay, and then by the chain rule, we have to multiply this by the derivative of this inner function. The derivative x over here is what?
1.
1. Okay, it's 1. And then adding the derivative of this y here with respect to x is y prime. Okay, now we're done with this. Okay, remember the outer and the inner. You need to use the chain rule. Okay, now what about the other side? The other side over here, notice that it's a product of two functions, this function and this function. So you have to use the product rule. So this one here, you use the chain rule. This one here, you use the product rule first. Okay. So use the product rule here. What do you get?
Y squared prime or times cosine x? What do you mean all the way down?
All right. Okay. Yeah, that's good. Now, I usually like to take care of the first one come, first one serve. I like to take care of the first one first. So y squared over here, differentiate that with respect to x. So I will get 2y, and then times. Remember the y here is a function of x. We have to times the derivative of y with respect to x. So times y prime. Okay. And then adding.
I think it's frozen again.
Okay, now you see it. Okay. Okay. So by the product rule over here, so we're going to have the derivative of this first function y squared, which is 2y times y prime. And then adding. Oh, no, sorry. Okay, the derivative of this first function here is 2y times y prime times, now we times the second function, so times cosine of x. The first function times the derivative of the second function. So the first function is y squared times the derivative of the second function. Okay, so the derivative of cosine x over here is negative sine x. So times negative sine x over here. Okay. Now remember, we're trying to solve for y. So we're trying to solve for y prime. So let's go ahead and see if I can isolate the y prime. So this y prime is inside this parenthesis. So let's go ahead and distribute. So we have cosine of x plus y plus.
Looks like it's frozen again.
Oh, it's frozen. Okay. It's going to take it's going to catch up a little bit when you freeze.
There it is.
So it's going to, the Wi-Fi, that's why. Okay. Okay. All right. Thank you. Okay. So because we're trying to solve for y prime, so I'm going to distribute over here to free this y prime from the parenthesis. So I got this y here. Now this one here, just copy. So 2y times, okay, and then y prime cosine x minus y squared sine x. Now when you solve for y prime, so y prime will be equal to, so we will have this term and this term together. So move this one over, so minus become plus. So this will become cosine x plus y squared sine x. And then divide by Now for these two, you bring them together. So, and take out the common factor y prime. So you have this 2y cosine x minus cosine x plus y. So 2y cosine x minus cosine of x plus y. So we solve for y prime. Question? Let's just do the algebra. Okay. So this is dy dx. Okay. So that's the answer over here. Okay. It's complicated, right? Yeah. A little bit.
Yes.
So it's let me see how much more do I have. I have this 1, 7. Okay, let's finish this last one, and then the rest I save for maybe make a video or save for next time. Okay. Okay, this next one here. This one here is actually very hard or impossible to solve for y. So we're going to use implicit differentiation to find y prime. Okay. So also find y double prime, first derivative and second derivative. So let's find the first derivative and then differentiate that again to find the second derivative. Okay. So implicit differentiation. So I don't have to solve for y. Instead, I can find y prime using implicit differentiation. So the first step here is to differentiate both sides of this equation with respect to x. Okay. So the first thing here is I'm going to differentiate both sides of this equation with respect to x. Okay. Now differentiate this with respect to x. I get 4x cubed. Differentiate this with respect to x. What do we get? 4y cubed. But that's not all. What else do I need to have?
Times y prime.
Times y prime. Done with this. On the other side, the derivative 16 with respect to x is 0. Okay. Now you solve for y prime. Okay. So solve for y prime. So y prime is going to be equal to negative x cubed over y cubed. So we found y prime. Now we're going to find y double prime. Okay. So how should we do it? So we're going to differentiate this, both sides of this equation, okay, with respect to x again. Okay. So this is the first one. Y double prime. So to find y, the second derivative y, we're going to differentiate this first derivative one more time. Okay, so differentiate that. Now, what kind of rule do I need to use?
Quotient.
Quotient rule, yes. So we're going to use the quotient rule first. And now we can also take out this negative sign here in front because it is a constant multiple. So negative sign in front. And we're going to use the quotient rule. The quotient rule says that we're going to differentiate the first function and then times the differentiate the function in the numerator times the function in the denominator, subtracting the function in the numerator times the derivative of the function in the denominator. And then all of this over the square of the denominator. So the derivative x cubed is 3x squared, and then now times y cubed minus, this is x cubed. The derivative of y cubed over here, the derivative of y cubed over here is, what is it?
3y squared times y prime.
You got it. Good job. 3y squared times y prime. And then in the denominator is y to the 6th power. Okay. Now let's simplify this a little bit. Now notice that this second derivative actually expressed in terms of first derivative right now. Okay. So how about we substitute y prime equal to this into this? Okay, to simplify. Now we have, so we're going to get negative 3x squared y cubed, and then I'm adding 3x to the 6th power over y to the 6th. Okay, because this y over here is y prime over here, it is negative x cubed over y cubed. Okay, now how can I simplify this a little bit? This is a complex expression. See, you have a quotient here and then a quotient, right? So to simplify this kind of complex expression, we will multiply the numerator and denominator here by y. So times by the LCD. Okay, because there's denominator. Okay, this one here, the y. So times the numerator and denominator here by y, then this is going to divide out. Okay, so it will simplify. So that will equal to negative 3x squared y to the 4 plus 3x to the 6, and then this is y to the 7. Now you might want to just leave it like this. However, this one could be simplified. Okay, let me see how you simplify this. This negative sign in front. Over here, you can take out a common factor, which is 3x squared. So let's take that out. And inside the parenthesis, you will have y to the 4 power plus x to the 4 power. This is y to the 7 power right here. Now, do you recognize this part right here? Do you recognize this part right here? X to the 4 plus y to the 4. That is given. Okay, so it was given in the problem, right?
16, right?
Yes, x to the 4 plus y to the 4 is equal to 16. So you can replace that by 16. So that's equal to 16. 16 times 3 is 48. So this is negative 48 x squared over y to the 7. This is the second derivative of that's the second derivative of y. A lot of work, right?
Yes.
Okay, so this part will teach you something. Sometimes when you find second derivative, you need to substitute the expression for y prime over here to simplify. So substitute here. And then sometimes you can use the information that's given in the problem to further simplify that expression right here. Okay. All right, I'm going to stop here. All right, so goodbye, everyone. Professor, how do you say that in French?
It's pretty good.
Sure. Professor?
Yeah,
You can also call me Madame. Madame Renee. And I have a French name. Isn't it cool? For this 2 weeks, you can call me Madame Renee. Different name, you know. So we're in a movie now. We're playing the movie of Madame Renee.